Have you ever looked at the stars and sun during the day and been curious about how they move around space and why the earth revolves around the sun? Galileo Galilei once looked up in the sky and asked himself the same questions and spent much of his life trying to discover their answers. Indeed, Galileo Galilei was a truth seeker and one of the most prominent figures in the scientific revolution. Telescope, the thermometer, pendulum, and compasses are some of the inventions he discovered which are useful in today's society. Galileo pioneered the use of the telescope for observing the night sky. His discoveries undermined traditional ideas about a perfect and unchanging cosmos with the Earth at its center. He used observation and experimentation to interrogate and challenge received wisdom and traditional ideas. For him, it wasn't enough that people in authority had been saying that something was true for centuries. He wanted to test these ideas and compare them to the evidence. At the time, this was quite a shocking idea and was one of the reasons that he got into trouble.
Galileo Galilei. He was an astronomer, mathematician, philosopher, and physicist. He was born on 15 February 1564 in Pisa, Duchy of Florence. His father's name was Vincenzo Galilei and mother's name was Giulia Aminotti. His father was a lutenist, composer, and music theorist by profession. Galileo enrolled at the University of Pisa for a medical degree. Financial difficulties cut short Galileo's education at the university, which he left in 1585 before earning his degree. Upon leaving university, Galileo set his mind to create a thermoscope, which was the precursor to the presently used thermometer. By publishing the book, The Little Balance, scholarly world recognized Galileo. Galileo took up the job as an instructor at Accademia dell'Arte del Disegno in Florence. In 1589, Galileo was promoted to the chair of mathematics at the University of Pisa, and by this time, Galileo conducted his famous experiment of dropping items of varied weight from the top of the Leaning Tower. In this experiment, Galileo rejected Aristotle's claim that speed of the falling object is directly proportional to its weight. Instead of Aristotle's view of motion, Galileo took Archimedean approach to the problem. Due to his rejection of Aristotelian view, Galileo gained an unpopular status within the society. In 1592, his contract was also not renewed at the University of Pisa, which led him to losing his position. Then, Galileo's patrons helped him secure the chair of mathematics at the University of Padua, which he served for 18 years. At the University of Padua, Galileo taught young students on the subjects of geometry, mechanics, and astronomy. Due to the death of his father, Galileo's family became dependent on him. But his income was too little to maintain his family. Galileo started to teaching privately. In 1610, Galileo discovered the moons revolving around Jupiter. He also claimed that there were a great number of stars that are there in the universe than those visible to naked eye. Impressed by the earth-shaking research made by Galileo, he was rewarded with an appointment as mathematician and philosopher of the Grand Duke of Tuscany. by publishing Discourse on Bodies in Water in his 1612. He again negated Aristotle's opinion that objects floated due to their flat shape. Instead, he argued that the flotation was caused due to the weight of the object in relation to the water it displaced. Following year, Galileo came up with his theory of sunspots. Again, Galileo contradicted Aristotelian doctrine that the sun was perfect by giving statement about Copernican theory earned him a ban from the church. With the emergence of a new pope, Urban VIII, who fortunately was a friend, admirer and patron of Galileo, Galileo resumed his works on astronomy. He was allowed to publish books as well, with the only condition that they provided an objective view and do not advocate Copernican theory. Galileo married Marina Gamba, and they got 3 children. After suffering from fever and heart palpitations, he died at Arcetri, Grand Duchy of Tuscany, Italy on 8 January 1642, at the age of 77. For playing a major role in the scientific revolution, Galileo earned the nickname Father of Modern Science. You cannot teach a man anything, you can only help him find it within himself, said Galileo Galilei.
Truly, he was the central figure of the scientific revolution of the 17th century. His role in the history of science was a critical one. In this video, we are going to answer the questions about the intellectual revolution of Galileo Galilei. Let's start!
For the first question, what is the intellectual revolution all about? The intellectual revolution that we are discussing is the Galilean revolution that revolutionizes the sciences of motion, astronomy, and strength of materials, and the development of scientific method. Following that, who are the key figures in the revolution?
The key figure of this revolution is Galileo Galilei. He was born on February 15, 1564 in Pisa, Italy, and died on January 8, 1642 in Arcetri near Florence. He was an Italian natural philosopher, astronomer, and mathematician. He is also the oldest son of Vincenzo Galilei, a musician who made important contributions to the theory and practice of music. Galileo has been called the father of observational astronomy, the father of modern physics, the father of the scientific method, and the father of modern science. Galileo studied speed and velocity, gravity and free fall, the principle of relativity, inertia, projectile motion, and also worked in applied science and technology, describing the properties of pendulums and hydrostatic balances. He invented the thermoscope and various military compasses and used the telescope for scientific observations of celestial objects. His contributions to observational astronomy include the telescopic confirmation of the phases of Venus, observation of the 4 largest satellites of Jupiter, observation of Saturn's rings, and the analysis of sunspots. He also wrote 6 books, which are The Starry Messenger, Discourse on Floating Bodies, Letters on the Sunspots, The Assayer, The Discourses on the 2 New Sciences, The 2 Chief World Systems, in which he shared to the world his discoveries.
For the third question, how did the revolution advance modern science and scientific thinking at that time?
Galileo's formulation of the circular inertia, the law of falling bodies, and the parabolic trajectories marked the beginning of a fundamental change in the study of motion. By 1609, he had determined that the distance fallen by a body is proportional to the square of elapsed time, the law of falling bodies, and that the trajectory of a projectile is a parabola. Both conclusions that contradicted Aristotelian physics, in which it says that the rate at which objects fall is proportional to their weight. His insistence that the book of nature was written in the language of mathematics changed natural philosophy from a verbal, qualitative account to a mathematical one in which experimentation became a recognized method of discovering the facts of nature.
Fourth, what controversies met the revolution?
His discoveries with the telescope revolutionized astronomy and paved the way for the acceptance of the Copernican heliocentric system. But his advocacy of that system eventually resulted in an inquisition process by the church against him. The Galileo affair began around 1610 and culminated with the trial and condemnation of Galileo Galilei by the Roman Catholic Inquisition in 1633. Galileo's discoveries were met with opposition within the Catholic Church, and in 1616, the Inquisition declared heliocentrism to be formally heretical. Heliocentric books were banned and Galileo was ordered to abstain from holding, teaching, or defending heliocentric ideas. Galileo was prosecuted for his support of heliocentrism, the astronomical model in which the Earth and other planets revolve around the Sun at the center of the universe.
Lastly, how has the contribution of the key figure impacted society in general? What are the practical applications today of the key figure's contribution to science?
Galileo Galilei had a huge impact on science after his death. He also paved way for the development of many theories that will be foundation to more complex discoveries. In fact, Galileo's work on forces helped Isaac Newton to develop his dynamics. Furthermore, Galileo Galilei fought against ignorance and blind beliefs by using scientific method of experimentation. The scientific method that we use now was thanks to him. We can now generate data through experimentation to conclude what will happen if we manipulate variables. Through this, we can also predict what will happen in the future on the topics such as climate change and global warming based on the gathered data of what is happening to the Earth right now.